it's going to be much easier. I'm just going to stay up here, and when we present, we can take a mask off. If you all would leave yours on, I would appreciate it. If I leave my teacher's console, I will go and put a mask on. So the topic today is computer-aided design and computer-aided manufacturing. This is what we do here. If you think about where the world was, most of you are too young to remember, but the 70s and 80s, we were hemorrhaging jobs. It was all going to Vietnam and Mexico and every other place under the sun. Anybody who made something was basically getting furloughed. So fast forward about 20 years. You get into the 90s and 2000s, and this logistics chain, everybody's fussing about, boats off the coast of Long Beach and all these things that are happening here. About 5 years ago or so, with the Boeing company, I'm not an educator by training. I'm an engineer. I spent most of my life at Hewlett Packard and the Boeing company with the short-term flying airplanes for the Marine Corps. So I basically came out of the user disciplines, and when I went to the Boeing company, they were literally hemorrhaging jobs. It was all going to Turkey and Korea and wherever the heck it was. So as the computer industry started becoming more powerful, and this thing, it used to take $1 million mainframe computer for us to do this thing we're looking at right here. This is computer-aided design. And then once upon a time, everything was on a piece of paper, and every time we'd actually have to draw it on a piece of paper and put it in a tube and ship it to some place, and it was very, very slow, very labor intensive, and costly. So if you were wanting to make 20 bucks an hour, it was kind of a tough thing to do, and some Vietnamese guy or Turk is willing to work for 11. So this is what made us bleed jobs. So in the late 80s, early 90s, the personal computer started cranking up. And then once we got to the point where we were all personal computer folks, this is what we're looking at, all these towers down here are the PCs. As we got to that world that had personal computers in it, and they were relatively inexpensive. They weren't a $2 million mainframe anymore. It was a $1,000 PC, which sounds like a lot of money, but relative to a $2 million mainframe, it wasn't. So as we started being able to create these things, and then we could create them quickly, and we could create programs from them. So most of the parts that I'm going to show you, these were conventional, and most of my students, they're going to draw something here, and then they're going to go and make it at our labs. But we have machines both here at KCC and some of our machines that are OIT. So they're going to go and make these things. This is the old 1960 way. You have to learn how to do it by hand first. And then as soon as you learn how to do it by hand, our next option is to go and say, now I want you to go and program these things, and I want them, the human brain has to program them. The human brain programs them, and the machine runs them. So the difference between 1979 and Uncle Ted, wherever he was working, and you, the future of this is being done by a machine, but only after you told it everything to do. You cannot. They were telling me back in the day, just remember, a computer, that box, is as smart as a toaster. It knows absolutely nothing. You are the motivating force. You're the brains behind this thing. So you go and teach this and say, make this program that does that. And then somebody else can go, let me go and show you one of the ones that, should have put that, there's a good one, and so I'll show you what happens when the human fails. This is this thing that we're going to go cut, all right? This is the thing that we decide we're going to make. So everything that was done by this was done by a machine. Can't remember who did this one. But you're going to go and say, I'm going to take this drawing off of AutoCAD. as an example, or SolidWorks or something. I'm going to take this this drawing, solid model out of SolidWorks, or two-dimensional 2D drawing out of AutoCAD, and I'm going to write a program. And if I do everything right, it looks like this. And if the human being does something wrong, it looks like this, and I'll pass this thing around. So the whole point is your brain makes something that is either correct or incorrect, and the computer is only going to do what you tell it to do. So if you tell it to, if you make an error like this, you're going to go and see, they'll pass this thing around because these are both the same part. If the human makes an error, that machine's going to make that error over and over and over and over again. If you make it correctly, that machine is going to do it correctly. And the whole point is, you don't have to spend your whole life turning out the next cup of coffee. You do anything you're going to do for 35,000 times is going to be done by a machine. Now, you can either fuss about the fact that machines are replacing me, or you can be the programmer of that machine. Because once upon a time, there were 16,000 machinists at the Boeing Company. We were down to about 4,000 at our low point when we started moving from this conventional stuff, doing it by hand, to doing this thing by machine. And now there's probably about 8,000, so we went back up again, but they're not doing the things that they were doing in 1970. They're making these programs, and the program is being run by, the minute I would go and finish my drawing, that's the thing you're looking at here. I'll show you the finished drawing here in a second. You finish the drawing, then you write that program that cuts that part, and the minute I'd go and take a part and I'd cut it maybe 3 times to prove that it was good in our labs at Boeing. And this is the same at General Electric, JELD-WIN, wherever the heck is. JELD-WIN stuff, they're being made in Bend, and it's being made in Latvia and Lithuania. It's being made in South Carolina. Everybody's doing the same thing. And once upon a time, that JELD-WIN guy had to put it in a piece of paper, put it in a tube, send it to Canada, and it would take days. When I get done with the program now and I make my first part, and the machinist says, go fast here, go slow there. Second part, okay, that's better. Third part, I'm happy. From that moment on, that job can both go to South Carolina, Bend, Oregon, Canada, and Lithuania. That minute. There's somebody in Lithuania cutting that JELD-WIN part, or that Boeing part. That's the future of the world. It doesn't live in Klamath Falls. A lot of the people that are doing work in Klamath Falls, or in Seattle, where I was, in Auburn, it's as soon as you get done with it, it's going all the way around the world. And these are the jobs that the world is going to be needing in the future. And if you do something 35,000 times a week, a computer's going to replace that. So take a look at these things. The one that has all the red and black on it was the program that was done correctly. And the one that has great big, ugly, nasty things on it was the one where the human being did something incorrect. So it is your brain that people are hiring. They're looking for your talent, not your hands and your eyes. 1966, I was looking for 2 eyes, 2 hands, a back, and somebody to pay attention. Now I'm looking for your brain. And a lot of the guys that I work with that are in their 70s, that the world is still looking for this skill, and they've retired and they're still doing the work because it's a skill that the world needs. And it's not like drywalling or pulling cable or something. You can do this, if you have 1 eye, 1 hand, and your brain still functions. People are willing to pay you a 6-figure salary. So, take a peek at that, pass that around. And you can kind of see when you do stuff right, you get one thing. When you do stuff wrong, you get another. So let me go and this is just a construction line. I'll show you what the part actually is going to go look like.
Is that the correct one?
Yeah, there you should see the one has a big boiled up metal where it just melted stuff, and the other was actually cutting and it made something that was useful. Ultimately, the usable thing in this case is going to be this part, and this is throwaway. So when you go and when the machine gets done cutting this thing, So the engineer is gonna go make this drawing. This is this thing right here. You're gonna go make that drawing, and then once the drawing, it's gonna go to stress. And the stress is gonna go and bend this thing and say, will this thing take the pressure that I ask? And you're going to go simulate it on a computer. Back when I first started on the B-2 program at Boeing, we had to build a B-2 and we had to break it. We literally jacked it and jacked it and jacked it and jacked it until we busted the whole thing. And then they came back and said there's sensors all over and said, okay, your part was too weak, you beef yours up. Your part was too beefy, you weaken it down. I don't want to carry any weight that I don't have to. I don't want to make the thing bulletproof. I want it to do exactly what I want. And so basically what they'd say is, there's an airplane, and it's going to go in with the worst typhoon we've ever heard of, and the entire world did this. I want to design that airplane with this factor of safety times 2.5. So it's twice as beefy as it needs to be. You don't want to make it right at that. If it fails, you die. So they're going to take that thing at 2.5, and then anything above that, I don't want that thing to be any stronger than that, because now I've got to go and make that car or train or that thing and make it stronger than it needs to be, and that costs me energy and fuel and metal and that kind of stuff. Some of the things that, how the world has changed, this is actually a 787 floor beam. This thing attached to the fuselage of the part, there's a floor beam that goes across, you're sitting on the top. They go and decide that I need to go and make this thing strong enough to have you go off a runway in New Delhi, slide into a mud bank, and you're being held on by this thing, and I'm going to take the 95th percentile man, the guy at 95% of weight and height, and when he comes to a stop, he won't come loose from the floor and kill the woman in front of him and her. So this is all simulation. And the point being is we don't have to build stuff and destroy it. We can simulate it right here on a computer. We can take that thing and say, I want to go and take like JELD-WIN. They'll take a door and they'll design that door, and they'll go and take a 2x4 and try to shoot it through that door at 100 feet per second. That's the worst hurricane that ever hit Miami. And if that 2x4 comes through the door, obviously we got to beef it up. So we're going to go and simulate all these things. The guy used to sit right in that chair there is now a first-level supervisor at JELD-WIN. The guy sat over there is in Columbia. The guy sat there, so he's a master sergeant at Kingsley Field. So you're going to the skill set that you learn in here is being needed by JELD-WIN, the Air Force, Columbia, Boeing. These are the skills of the 21st century, to where it's I'm buying your brain and not your hands. Hands, at some point as AI comes in, artificial intelligence, it's gonna learn how to flip burgers, it's gonna learn how to go and make coffee at Dutch Brothers. Here, everything is different every day, and you're gonna have to go and make that machine that would replace you. You're gonna program that machine to do that thing, whether it is flipping burgers, making parts, pretty much anything you can think of. And the world that you're going to go into, when I walked in, there was simply steel and aluminum. Now we've got titanium. It's all over the place. This is as strong as steel and lighter than aluminum. So you got titanium showing up. You have these composites, CFRP. This is basically graphite cloth impregnated in plastic, and you cook it. This thing here is if you go and see the fuselage of the airplane, this is the 28-foot diameter of the fuselage of the airplane. You're here, it's 400 mile an hour wind and 70 degrees below zero out here. That's what's between you and the world, right there. Again, this is about just about the strength of steel, and I'll let you touch it. It doesn't weigh anything, and these are the materials that the world's going to go see now. That wing that goes from the root of the wing all the way to the wingtip, this is what's supporting that, 240,000 pound airplane. That I-beam, there's a series of I-beams in those wings. Each of these things is laid up on a computer, and then somebody's going to go and take these contour tape laminating machines and lay these series. You can almost see the different layers in here. These are just think of it as almost like making a shirt. It's going to be a graphite cloth with plastic in it. And we're going to lay a bazillion these little layers up, and then we're going to cook it in a thing called an autoclave. It's a big cylinder. They put it under pressure. If anybody's gone to the bottom of the pool, right? Swim to the bottom of the pool and you feel all the pressure on your ears. Yeah, you can start getting that 2 and 3 and 4 atmospheres. This is going to be 100 times that much, at about 400 degrees, and they're going to cook it. When it comes back out, you have this part. That's the equivalent of that wing spar that holds everybody's weight up. Same thing in that truck where he's got something underneath the foot. All these things that we've been doing conventionally and with aluminum and steel are turning into AutoCAD and titanium and graphite. So every product you make, that the world's making, is changing. Right now, that guy I was telling you about, that's the first level guy at JW, he's a research and development guy, and they're looking at how do we go and make composite windows. I don't want to make wood anymore on certain applications. A lot of the wood's going to stay. Some of it's not, depending on the application, how you're going to use it. And they're saying, I want to go and see what pieces could we go and make this thing out of composites that might not be harmed by water or sunlight or something. So everybody's looking at how do I make the cheapest, best products in the world, and if I want to go do that thing, now how do I go and make them? And do I have the people that have that skill to go do that thing? One of the reasons that not IntelFab. Some of the companies are coming to Klamath. We've got a 3D printing company that just moved in from Seattle. He went and said, that everything's too expensive, everything's a no, everything's too difficult. So he left Seattle and he's right off Main Street. He's a guy who does 3D printing. That's this thing. In my SolidWorks class, you're going to go and create this solid on the computer. It's a solid piece of geometry. And then once you make that thing, we're going to go over in the 5 building and we're going to 3D print that solid piece of geometry. This is the bolt and nut that you might want to make. A lot of these things are all printed. This is the future. Anybody who's under about 35, your world's going to look more like this than this in 20 years. We're not going to go and take a 100-pound blob of something and cut away 80 pounds and say, okay, I'm done. The future is going to be, I'm going to go build this thing up. And I'm going to take this solid model, which I'm going to make in SolidWorks, and I'm going to go print this, literally print this thing up. This is all plastic, that's all we have here. When I was at Boeing, this is 3D printed titanium. This is where, basically, if you're going to have a 2-pound part, I'm going to make a 2-pound, 2-ounce part with 3D printing, and then finish machining. My wife actually has a titanium hip. That's what they're going to do. They're going to go scan her. You're not going to get a small, medium, large, extra large like we've been doing historically, just like you buy a jacket. You're going to go and scan Diane and then make her hip. Not yours, hers. So this is the world where you're going to go and use this new technology to make stuff that is very custom built. A lot of guys left Boeing. You know, they said, I got a job down in Las Vegas. And about the third or fourth guy that went down there, what are you guys doing down there? And it was body parts, man. We're making body parts. And they were making elbows and hips and knees. So these are the skills where you have to go and take that scan, a CAT scan, of my wife as an example, and then they turn that CAT scan into this 3D model. Then you turn the 3D model into 3D printed piece of geometry. You have to finish machine it because you notice how rough this is. It has to be perfect. And then you're going to go and basically put it in her femur, where they take the old bone off the top of yours. They take this thing, looks like a bayonet with a ball on it, sink it down inside. It was really gory surgery, but the whole point was she can now do anything she wants. This new technology gives you the ability to do that. So here's the plastic 3D stuff. You can go see those. Let's start the metal 3D printing on that side. Yes. Yeah, and we'll go past around. So the point being is you learn how to go and you see that this was how we started this thing. It just starts with an idea, and you can see that in front of you. Let me go re-show that thing. I turn yours a little bit more so I can see it. Net. That's what to answer. And then I'm going to go show. Do you have something projected on your screen yet? Nope.
Yeah.
See it here. When it pops up, I can see it.
Sunny day green.
Now you can see it on the screen now. I was trying to project it onto your screens because this is some of the technology that we have the ability to use here.
Oh wow.
And
And in my foot. This is in
tutor console. Why is that thing not showing? Anyway, you can see it up on mine. Normally I don't know why I can't project it onto your screen, so you should be able to see it on yours. But so you start off with this idea. Somebody says, I need to make this Geneva cam. And so you're going to go start with a series of circles, relatively simple things. And then you're going to go turn it into this part. Okay? So once I have, you can see this cam where I can go and say, I'm only going to make this piece. And I'm going to mirror it, and then I'm going to copy it 6 times. So you take something that used to be a rather large endeavor, and it turns into, I only have to make that chunk right there. And then I mirror that chunk, and I copy it 6 times, and in 10 minutes, I have a drawing that I'm going to go start making parts. And in a couple more hours, I'm going to make that program. And after I make my first article, I can start making things that people can use. This used to be, I'd be a week drawing something, and then I would be another couple of weeks programming something, and then I'd to have this machine tryout because I can't simulate things. Now it's all in a couple of minutes. And this is, if you try to go and compete with the way you did stuff in 1970, you're out of business. These are the skills of 2010 and beyond. So this is one of the programs that are bringing companies to Klamath Falls. And a lot of the people that are in Klamath Falls that have this kind of skill set are working outside. One of the guys that I go to church with, he literally works, he has a house on 140, came from Seattle, and he literally works for Microsoft. As a matter of fact, he still works for Microsoft. He just works from here and not Seattle. He's done with Seattle. It's too expensive, too crowded, too something. So he came down here, bought 14 acres, and he lives off 140, and he works for Microsoft in Redmond. This is the difference in work, how work works. Once upon a time, if you want to work for General Electric, you had to go to Cleveland and live in Cleveland and go to a factory in Cleveland and go to an office in Cleveland. You know, when I left the Boeing company, a lot of the people were saying, I want to retire. One guy was, his wife was Hawaiian. And I said, I've been dragging her all around the world forever. She wants to go home. Her mom's sick. So he said, I got to retire early. So they went and said, well, can we still use you as a contract worker? So from Molokai, he still works for Boeing in Seattle. This is the job of the future, and it's the way the world's going to work in the future. Certain people still have to go to the factory and stack wood or foam or something like that, but more and more people are going to make their living drawing something up, making a three-dimensional drawing of it, doing that analysis, the computer analysis to say how much pressure can this take before it breaks, make the program, run the prototype program. Like I said, that guy was sitting back there, he makes these prototype programs and says, does this work? And then after that, the parts can be made any place. But the thinking part, the part that has the talent attached to it, the one that has the big money around, is the thinking part. You can have anybody punch the green button to make the machine stop, and when the button goes red, we take it off and put another piece and hit the button again. Those people are going to get a certain amount of money for the rest of their lives. Whoever is going to go and has the intellect to go and make the program, because when it comes down to it, all you're saying is, I have this thing. There's a line, there's a radius, there's a line, there's a radius, there's a line, there's a radius. Follow that line to hit the radius, follow that radius to hit the line. That is that program. This is what machines read. You do have to learn a new language. The downside or upside to this is you do have to learn a new language. Just like any other language. If you know how to speak Chinese, French, German, whatever that thing is, you now can go and function in France if you can speak French. Here, you notice that we have, this is how humans think something. Mill something, and then dwell, stop for a second. This is how we think. The machine doesn't, remember, it's as smart as a toaster. It doesn't know anything. You're just going to go and tell it, if you want to draw a line and go around a corner and then take another line. You're going to have this GO1, which is linear interp, go along that line. Then you're going to tell it GO2, because you're now going to go around a circle until you hit that line, and then GO1. So machines, you're telling it everything, and you have to learn how to speak machine. Everybody in my class has to go and say, learn this new language, learn this machining French. Because the machine understands that, and humans understand that. If you say, make a hole, go to this point in X and Y, start at that place, go all the way to the bottom, and come back up. We understand that as go to that place, drill all the way through, come back up. The machine says, go to that place, and then you're going to have an X value of something. Go to, if you wanted to go, the world started here, and I wanted you to go over 1 inch and up 1 inch, you'd go G01, X1, Y1. You're going to go over an X1, going up to Y1, and you're going to drill a hole. You have to understand that language, and this is what we do in our NC numerical controlled machining classes. We've had about 20-25% females, about 70-75% males on any given year. This used to be it was all males all the time in 1966. When you went down to the factory, when I went down to a Hewlett-Packard factory in 1976, it was coolant and nasty and dark, and everybody was mucking around with machines by hand. As this became numerical controlled stuff, 85% of your time you're in front of a computer, and 15% of your time you go down to this basically it's a computer-controlled machine, and you take your thumb drive, you stick it in there, and it's going to go and make this part, or make the composite parts that you saw. So you're seeing more people that normally weren't in factories. My daughter, she's a QA analyst for a Japanese company in Portland. She came out of OIT. We do the same series of courses that OIT does. They go on to take a junior and senior year and things, but we basically have that same sequence of courses that OIT has in computer-aided design and computer-aided manufacturing. About half of our students go to industry. About half go to OIT and OSU. So it takes the same series of courses, and if you're looking just to go to IntelliFab or JELD-WIN or something, you can go straight to work. Or the other one is you can go up to OIT and OSU. So it kind of depends on how you see your future. So all these things have that capacity to teach you how to go and use the skills that are going to be used in the future. And when you get done with something, we'll have a lot of these. You see that G and M codes there. The other thing we have to have is you have to learn how to use the tools of the 21st century. Everybody's used a scale. Now we have a scale that we have to figure out. This is what my daughter does as an example. This is quality assurance. We have all that stuff back in that granite table behind you, to where you go and say, you have to prove that the granite table with that vertical thing on the back, that's a height indicator. About 20% of the people that are going to go and come through this program are never going to make anything. They're going to prove that the thing that was made was correct and it's useful. So you have that ability to go and say, I need to go and this thing needs to be so many thousands thick. And if you learn how to read this piece of equipment, this is what QA people do. And all these little lines on the back on this side tell you, how thick is that? Is that useful? Can I accept it, or do I have to throw it away? So this is that's what my daughter does. She goes and takes ceramics. She ended up doing quality assurance for a Japanese company that makes the precursor for Intel chips. All she does is prove that all those things that we made, either we have to remelt it and do it over again, or it's useful. And a lot of the people are going to come out of this guy that used to work, he's a JELD-WIN analyst, the guy that you sit in that corner there. He's a JELD-WIN guy that does QA at JELD-WIN. It's the skill set of, do you know how to speak the language? Do you know how to use the tools? Can you go and draw me that thing that I'm going to have to say, because I'm going to send this drawing. This is going to get made in Bend and Lithuania. So when you get done with this thing, this is going to go to Bend in Lithuania the minute you get done. Now the tool is going to get made right here. The piece of steel that's going to form it is going to get made here in Klamath. This is the nature of work. Work is all over the world. And if you have that skill that is in demand, you're going to go around the world. Personally, I've been to Italy and India, England, Japan, Korea. Friends of mine, when the Twin Towers got hit, and aviation just shut down for like 3 years. So everybody kind of remembers that time period. A lot of my friends ended up going off to Holland and Taiwan. We just didn't, in our industry, we were just dead for about 2 years. A lot of the folks that I knew either went to Taiwan or went to Holland and worked until everything kind of cranked back up the United States. The whole point, this is very, the word called fungible. It's movable. This is not just here in Klamath or in the United States or in Oregon. Like I said, they talk about the guy who worked here in Klamath and he's working for Microsoft up in Redmond. If you were in the information and intelligence business, you're going to be working for who knows where, who and where. I'm sure my daughter never thought she was going to be working for a Japanese company in Portland making the precursor for Intel chips. This is the way of the way of the world as far as that goes. It's the new way to go goes. So, any questions before, just for real quick, just on the stuff I've gone over to the moment? Yeah, go ahead.
So, like, with this type of software, like, would you also teach us, like, how to work, operate, like, CNC machines and things like that?
Yep.
Would that be the same?
That is it.
That is it? Okay.
When you get done, the tomorrow afternoon, this is the first week of the second NC course. This is the stuff you do on the first course. These are done by hand, and they're hand machines, 1966 style. You have to know how to do stuff the 1966 way. The very next course, this is the first project of quarter number 2. There's 3 quarters. All they're doing is they're flattening that face, they're going around that profile, and they're drilling 4 holes. It's very, very simple. But they're programming it, they're not running it. The machine, then we have 2 machines up at OIT that are ours, and they're going to go do this first project. We're going to program it today, and they'll be cutting it on Thursday. Ultimately, when they get done with the 3rd quarter, and this is all being done on our machines, either over in the 5 building. We have some machines over in the 5 building over at OIT. All of our welding equipment, our welding instructors are at OIT. Majority of our our machining equipment is actually at OIT's lab also. So we do some of it here, machining, but when you go and do these numerical control machines, our 2 machines are at OIT. So all the instruction is in this room. We write the programs in this room, and then we walk down to OIT and put that thumb drive in a machine, and then the guy who wrote the program is going to go run it at OIT on our machines. So yes, all of this NC stuff is going to be done on our machines, and you're going to program them here, and you're going to walk down to OIT. We'll get in front of our machines with a thumb drive and run them there.
Cool.
3D printing stuff. This is one of my students was a master sergeant at the Air Force, and he 3D printed 30 millimeter anti-tank round and a 20 millimeter air-to-air round. So this is 3D printing. This is all composite again, and those things are done over in the 5 building. Our 3D printing machine is over in the 5. All these red, blue, and these black composite pieces, 3D prints here, are done here on campus. So you go and learn how to do 2-dimensional stuff, then you make 3-dimensional models in SolidWorks. Take those 3-dimensional models and make 3D prints out of them, or turn them into programs. And that program is the thing that it is going to go and make all this stuff. You're not touching the machine. The machine is doing it itself, but you put all that intelligence sitting in that chair right there. So you're going to spend 85% of your time there, 15% of your time proving something out.
Cool.
Next, you got anything else?
One more question.
Yeah, go ahead.
So, like, you were saying that on the Boeing, like, on one of those parts, they cover it in, like, it's almost like a tape.
Yeah.
Is it kind of like when you, what do they call that? Not plasti dip, but you what'd you say?
Marble grab?
Yeah, kind of like that. But so, like, I forget what it's called, but it's like
You laminate it?
Yeah.
Yeah. This stuff is it's just think of it if it was a cotton shirt, except the cotton is now composite fibers. And they run this way and that way when they weave them. And they're impregnated with a plastic. And the plastic can go up, it's not standard plastic like a bag, it can go up to 600 degrees. And you're going to lay that one ply is going to be at 0 degrees, and the other is going to be at 45, and negative 45, and 90, and negative 90 to give you strength in different directions. And this is where you're going to lay this thing up on this computer. And then you're going to go and take that machine that takes this composite tape, 1, 3, 6, 2 feet, and you're going to, this NC machine's going to go lay it out. When I started on the B2 program, They literally had 1,500 seamstresses, women, in a big Herkin room. And they were cutting out these plies of whatever this thing was with a set of scissors. Because the whole point is now, not all this stuff is flat. Sometimes it goes into a gully, sometimes it goes over a top, and said, who knows how to take something like cloth and turn it into an armpit of a shirt? If you ever done gathers. So they went and got a bunch of seamstresses and said, you're working for the Boeing company, and for the first 7 B-2 bombers were built by a bunch of 100% women, cutting stuff out and laying them up. I mean, the mechanics laid them up, and a bunch of seamstresses were cutting these T's and L's, whatever the shape that was that we needed. In the meantime, I'm working with Japanese companies, American companies, trying to get a machine that has a tape. And you just go and say, go in X, Y, and Z and lay that tape. And it lays tape 24 hours a day, 7 days a week. And it's this composite fiber. You can, the one black part, you can actually see the cloth. Yeah, you can actually see the cloth. You can see how it's woven together, and it has plastic on both sides, and it has to be refrigerated. There's a bunch of it's kind of a fussy process, but once you have they have it all scoped out, you got to keep it cool. You have to do these things. When you get done, you have to get it to room temperature, and as soon as it gets to room temperature, you go and use it up. So it's just learning how to go and use the tools and the materials of this generation. And if you go and look at any modern wheelchair, golf club, fishing rod, the nose of any truck now, it's made of composites. It's not made of the stuff that was made in 1988. So the whole way we do work, I don't have to live in Klamath to make money. I don't have to live in Seattle to work in Seattle. When I get done with something, like the guy who moved to Hawaii, he still works for the Boeing company in Seattle. So that the nature of work is changing. How you work, where you work, what you're doing is totally different. But you have to have this skill set that they're looking for. Wilson Art left Tacoma, Washington, came to Klamath Falls for this skill set. Companies that were looking at Klamath before, you know who IKEA is? IKEA was looking to come to Klamath, but they didn't have high-tech workers. So they went to Yakima, Washington instead. Since then, we now make high-tech workers, and these companies can come here. So this is the job of the future. I mean, you notice that once upon a time, every store, when you checked out, had somebody at a cash register. Now you go into Safeway and Fred Meyer's, and you got 20 cash registers with just one person. That is going to accelerate. There are going to be fewer and fewer people in sales. More, I mean, because you just don't need them. And like the AI guys have said, if I can ever get a machine that can differentiate between a grapefruit and an orange, I don't need any salespeople anymore. If it can tell the difference between a grapefruit and orange, I don't need somebody sitting at that register. The machine's going to go do it, and you're going to go through and throw your 3 grapefruit and 7 oranges, and it's going to know the difference. So anything that doesn't take some thinking, and anything that you're going to do more than 100 times a day is going to be done by a machine. Make sure that you're in a function that needs a human brain. Because that machine at OIT, or at Boeing, or General Electric, until you give it motive force, is stupid. And you are the thing that give it that motive force. Otherwise, that cool whiz-bang robot's going to sit there forever. And every time that engineer comes and says, I need something a little bit different, talking about my wife's hip again, every hip is different. Every time somebody comes in and says, I need a shoulder for that man, that woman, somebody has to go and build that thing. Because we're going from a small, medium, large, extra large world to custom. And that's where the world's heading. And you want to make sure you're on this side of the fence. Anything else I can do for you? Because I got the AutoCAD class coming in here in about 10 minutes. They're going to go and do this today. And then 2 hours from now, they're going to program this at noon. And then next Tuesday, or next Thursday, we're going to take this and go run this at OIT, and this will be the first time, because last quarter, they built all these things, turning stuff by hand like 1960. This Thursday, they'll be in 1990. 13 weeks from now on Thursday, they'll be in 2020. So we're working you into, each one is a little bit different. You're basically moving decades in technology. This is the 1970 version. This is the 1980, 1990 version. They're going to use a set of software that's developed during the 80s. And next quarter, they're going to use a bunch of software that's going to be used in the year 2010 and 2020. That's that sequence where we're taking everybody through. And a lot of the things, just as an aside, a lot of the mathematics that I had to understand when I went through college, it was not just how you do it, but the mechanics of doing it. Now, a lot of this software, the high-end calculus is physically in the box. I have to tell it the things that I know, and it has to figure out the thing I don't know. But a lot of you have to know why now, not as much how. In 1970, 1985, when I got out of OIT, I had to know the how and the why. Now you have to know, just give the software the things that it needs to know. It can give you the answer. You know, the ability, the concept that you have to go crank something out now, actually move through the mathematics. You just have to know to give it the things you need. Like the whole time I was at Boeing, I probably did less than half a dozen calculus equations, and I'd gotten so bad at it that 5 out of 6 I was wrong. Had to go to the math physics guys. It's the most of that high order mathematics is in the software now. Now you just have to make sure you're giving it the right variables. It will do the grinding and cranking, but you have to understand the how, and I mean the why you're doing something. Give it the thing that it needs to know, and it'll give you the answer. But you have to make sure that you give it the right variables, and it can. So even the way we create things now is kind of built around the machines that are our tools. And with that, I got about 5 minutes before my guys get in here. Anything else from the floor? Good. Okay.